Well, I began the dissection of my front truck with the sound trigger magnet and the reed switch because it had stopped working. It didn't work this morning. And I thought it was the position of the switch. And then I found this black wire hanging off in space, and I thought, oh no, my power pickup wire had come off on that particular set. But then when I started to dissect it, the power pickup wire is fully attached. Both sides. Then I realized, oh no, that's my reed switch pickup had broken solder joint. And I remember soldering that was tight, a little tight, and I had to unsolder and resolder, and so it's possible I did a cold solder joint, which is just a weak joint that does not hold. So now I'm in a quandary. I don't know if I really need to do what I want to do, or what I think I need to do. What I thought I needed to do was to come up with a box to hold the reed switch and have the switch hanging under the axle. So I started to come up with the design for that, but now I'm wondering if that may be overkill. If I resolder this, is it going to work the way I need it to? So I'm guessing what I should do is resolder it, I guess, and maybe try to bend that lead down a little more without breaking the glass, and making sure everything is in good alignment, and then just reassemble it and test it again, because I'm pretty sure I'm going to get the Chuff sound, because I had the Chuff sound late yesterday pretty reliably. Heck. Well, I may go ahead and do that just so I can have this, know this is okay. And then I'm going to start printing. I have new chassis dimensions already. I've already moved some holes to make room for the bigger speaker. I'm going to have to put in the big speakers. The only way I can make this thing sound right. And I also have to fuss about the fan, because the fan stopped near the end of the exercise. So I got to find out what happened there. But I got to have the fan working to put the body on. Although this is not the real body. This body is going to get 3D printed. And my idea, I can tell you right now, I'll move this aside since we're probably not going to do this, or at least not now. My idea for the rear of this piece right here is to, I'm really hard on these, is to have this thing, an opening, something like this, a big opening right in the back where the fan will just blow its air out, okay? But then I'm going to have a standoff like this to cover it, and air would then come out the sides. And I'll show you how that will look if I do a side view. So here it is. I'll do it in like it's three-dimensional. Okay, so there's the hole. All right, and the air's coming out. Fans here, blowing air out. So I'm going to have a little standoff right here, and then I'm going to put this plate over it like this. You see? So the air can come out, can go this way, and go this way, and go that way, and come this way. And air will come out, but when you look at it, what you'll see, I'm thinking, if I do it like I want, what you'll see is you'll see something like this, but the hole is going to be in here, so you won't really see the hole. You'll just see this plate on the back, like an insulator maybe, or something like that, but the air will be coming out like that. That's the idea, how I can get the fan to work without making this thing look like it's all chopped up and has holes in it, because it's full of digital electronics instead of water and coal. I don't know. Let me know what you think. Leon, if you see this, let me know if you think that's a good idea. And with that, I'm going to probably resolder this and test it. Okay. Guess that's a quickie for you, huh? The engine, I want to say, is running like a champ. It's so smooth. And I've been thinking about that also, because it needs 13 volts to run, right? And here's how the fields come. So it has these fields, and there's a pair of arc magnets like this. They fit in these slots here, and then there's a square here where I put in a rectangular magnet. I call those boosters. And the armature's in here, and it rotates depending on the fields that are inside the armature, how they work. So if this is north and this is south, this becomes south, this becomes north, and this probably becomes north. And then it spins, so it's pulling this, and it's pulling this, and it's pushing this, and they end up rotating, and then they switch because there's two brushes, right? And so the brushes will touch on two of the things at a time, and they'll switch as they rotate. So this one will rotate, and it'll become south, it'll become north, whatever it works. Okay. Now, what I'm thinking is I need 13 volts, 12 to 13 volts to get smooth motion, and it will fly at higher, okay? So you can go up to 20 volts, the thing will fly. Now, if you wanted motion at lower voltage, you think about what's getting the voltage. It's not the magnets. The magnets are permanent and they're static. They have a magnetism, whatever it is. But what you're changing is the magnetization, you will, the electrical current of these fields on the armature. So if you have low, let's say we have low voltage at the armature, and you want this to move, and you want it to be a push or a pull. In order for this, and this is boosted, so if we boost it, we're increasing the newtons or Newton magnets or whatever it's called. Okay, we're increasing the power of the magnet, and you're increasing the resistance to motion as well. If I lower this, or if I lower this power, let's say for argument's sake I'm running at 60, and if I lowered it to 40, and if this required 30 to operate, and I lowered this to third, would this only require 20 to operate? So maybe if I'm running at, say, 13 here, and I lowered this could run at 9, say 9, right? 9 volts would give us motion, but it might not fly, when I'm up to 17 volts. It may not fly as well because there's less power to affect that energy. I don't know. Okay. Couple things I can do. I can run this without the boosters, just leave them out. It's easy to do. It's built so that you can. Just put in arcs and try one on a test bed, right? Then I do have several types of magnets. I have what I call thin man, I have regular, and then I got fat man. So I could try it with none, just the arc. Okay, test that, test it with thin, test it with medium, test it with fat, and determine the the voltage at start. What is it? What's the voltage at start here, 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 and here? And that will tell us if it starts, if we know it starts here around 13, but that's without a load. That's with a load. That's a difference. Torque, is energy, so you got to have more. It may be a smaller magnet won't pull the. Okay, let's say this pulls 20 cars, and it starts at 13. What if this one starts at, let's say, 10, but it'll only pull 15 cars? And what if this one starts at 5 volts, but it's only going to pull 5 cars? Maybe, and then this one starts at, let's say, 15, and it pulls 25 cars. Fat man. It could be some scale like that, where the lower voltage, the earlier it starts, but the less torque pulling power it has. I don't know. And then what's the trade-off? You say the Atlantics can only do 5 cars forever. You say that, or you give people an option. You can put this one in, you can take it out, you can put this one in, because that's all you're doing, just switching this whole assembly out And it's easy. It's 2 bolts. Once you get the engine off, 2 bolts. Boom, boom. We'll think about it. If you have comments on this, feedback on this, motor power to torque to low speed starts, you know, that kind of stuff. I mean, it'd be sad if you had a big engine with a lot of trains and you could only, you know, it'd only start at 15. It'd be crawling. It might be crawling at 15. I don't know. You know, how low is low enough? Some of these, you know, the Mike's Train House stuff, you use pulse width modulation. It's a different kind of a control technique. And you can start it at 1 mile an hour, simulated, 1 mile an hour. I mean, you just tell it 1 click and it just takes off. It's go very slow, very slow. And we can do pulse width modulation. It's in our R&D kit. We're not there yet, but we can. So compromise this as far as a vintage, let's say, the vintage conversion. And then for the true next gen stuff, you know, like level 1, level 2. You know, level 2, we can get the pulse width and get the creepy crawly stuff. But I don't know. I'll do this test and we can make it see what happens. All right, gang. All right, sorry for all that. Later.